Greetings and welcome to another lecture in Introductory Psychology. This one involves the fascinating, if confusing, topic of correlations. As you probably already know, there's two basic types of research. There's experiments that give you cause and effect, and there's descriptive research that gives you correlations, that gives you that there is a relationship. So, we're going to go into correlations in a little more detail. And yes, I'm going to be repeating things over and over and over again. Because I'm warning you ahead of time, this is one of the 3 or 4 most difficult things that students find they need to remember for tests. Mostly because in some ways it contradicts what you have already learned. First of all, as I might have mentioned before, correlation does not give you cause and effect. It does not control for all the other things that could be causing this effect that you're looking at. And so therefore, all it can do is tell you that there is a relationship between these two variables, between these two things. That somehow these two things are related, but it cannot tell you what that relationship is. It might be cause and effect, it might not be. You cannot assume with a correlation that it is. It could be that A causes B or B causes A or B are both caused by C with a little d, and when the moon is full and, Jupiter aligns with Mars. But you can't know that. All you can know is that these two things are related. For instance, I suspect that it is true that a person's height is correlated with the length of their feet. It's also correlated with their weight, by the way, although not as nicely. Taller people tend to have longer feet. Shorter people tend to have shorter feet. Now, is this cause and effect? Does being this height cause your foot to be that size? If I took a person and put them on the rack and stretched them out so they were taller, would their foot size change? Or if I took their feet and scrunched them down like in foot binding, would their height? No. No. Because the one doesn't cause the other. They're both caused by a number of factors, including genetics, as well as things like human growth hormone. Okay? But they are correlated. Taller the person, larger the feet. Shorter the person, smaller the feet. It's correlated. Generally, the larger the person, the more they weigh. Although this is not as well correlated, because I know some very short people who weigh one hell of a lot. And some very tall people who don't weigh much at all. So that's a correlation as well, but it's not as strong. But it's a correlation. Okay? And, if you weigh more, you're not suddenly going to grow taller. It's not cause and effect. Okay? Now, what information you get in terms of correlation is usually in the form of what's called a correlation coefficient. Coefficient is just a fancy word for number. It's also statistic is a fancy word for number too. Don't get scared. We're not going to learn how to create correlations. You'll learn that in your statistics class, and you shouldn't be scared then either. Okay? It's not that scary. It looks scary, but it's not that scary, like a lot of things in the world. A correlation is a number that ranges from 0 up to 1, either plus or minus. And here's where it gets complicated. Well, actually, the 0 is not complicated. A 0 correlation suggests that there is no relationship at all between the variables. There is a 0 correlation, for instance, between the size of my foot and what time the sun comes up in the morning. No connection whatsoever. And I'm very glad of that, because I wouldn't want the responsibility. Okay, that's a 0 correlation, no connection. And they go all the way up to a correlation of 1. Now, where it gets complicated, now correlation 1 is a very, very strong correlation. The thing is, though, the plus and the minus that you see there have nothing to do with the size of the correlation, and this is part of the complicated thing. The first one, of course, is correlations don't get cause and effect. But the second is that the plus and the minus have nothing to do with the size of the correlation. Here, get ready and write this down. Minus 0.3 equals plus 0.3 if they're a correlation. A correlation of minus 0.3 is the exact same size as a correlation of plus 0.3. The plus and the minus do not mean what you have learned that they mean in all of those math classes that you've taken or will take. Not for correlations. This is where it gets tricky. Because if there just so happens to be a question at some point, and I would kind of count on it on the final if nowhere else, where I ask you what is the largest correlation or what is the strongest correlation, minus 0.7 is stronger than plus 0.5. And I'm going to tell you right now how to make sure you get that right. When you see that question, on which of these is larger, the largest, or which of these is the smallest, which is the strongest, which is the weakest, take your number 2 pencil. Actually, you won't have a number 2 pencil, but take a writing implement or take your mind and cross out the plus and the minus. The plus and the minus, when it comes to sizes of correlation, are simply there to confuse you. They have nothing to do with the size. If you speak math, you could think of this as that correlation size goes from 0 to the absolute value of 1. Whether it's plus 1 or minus 1, it doesn't matter. Okay? Now, the plus and the minus do have meaning. They're not completely there just to confuse you. Only when you basically are looking for the size are they there to confuse you. Otherwise, they do indeed give you useful information. For instance, we have what's called a positive correlation. It has the plus in front of it. Now, this is not a value judgment. A positive correlation is not a good thing or even a better thing. It's simply a thing. What the plus means is that both of those variables vary in the same direction. They vary in the same direction. When one gets larger, the other gets larger. When one gets smaller, the other gets smaller. Height and foot size are positive correlations. The taller you are, generally the larger your foot. Height and weight are positive correlations. Generally, the larger you are, the more you weigh. The taller you are, the more you weigh. Okay? I will say, as I mentioned before, that height and foot size is probably a correlation of maybe plus 0.5. Height and weight these days is probably plus 0.2, for the aforementioned fact that these days, what with most everybody being fat in one form or another, you can't really rely on height to figure out how much someone will weigh. But you can rely a little more on their foot size. It's not complete, but it's better. It's stronger. Okay? So with a positive correlation, they both vary in the same direction. One goes up, other goes up, one goes down, other goes up. 3 guesses as to what a negative correlation is, and the first 2 don't count. Yes, indeed, with a negative correlation, they work in opposite directions. When one gets larger, the other gets smaller. Again, if you speak math, they are inverse. Okay? One gets larger, the other gets smaller. One gets smaller, the other gets larger. They're still related. Okay? They're still related. For instance, in face-to-face classes, there is a delightful negative correlation between the number of absences a person has and their grade. Now, again, it's not a value judgment. It sounds like it, but negative simply says when one goes up, the other goes down. And I did this research, I should have published it, where I took my 5 classes at a different school. I had no attendance policy, but I kept track of attendance. And I found that the people who missed the most classes got the lowest grade. Now, we don't know exactly what the cause and effect is there because this is a correlation. It could be that when people missed classes that they didn't get the information they needed to do well on the test, which is what I kind of pushed. It might also be that more responsible and conscientious people were in class, and they are also the ones more likely to study enough and properly to get good grades. It might be that people who missed more classes were sick, and therefore they couldn't concentrate and wouldn't do well. Maybe people who missed more classes had to work all the time or had a family emergency, or maybe they simply didn't care. Okay, and therefore, I mean, all of those things could explain why attendance and grades are negatively correlated, but we don't know which one it is. Not without an experiment, not without ruling out everything except that one, which I didn't bother to do. So remember, positive correlation, they both move in the same direction. Negative correlation, they move in opposite directions. They move in different directions. Now, please do remember, I'm going to repeat this a few more times simply because people forget this on tests and finals and other useful times. Correlation does not give you cause and effect. Okay? If you hear that something is correlated, all you know is that they're related somehow. You don't know what the relationship is. Now, correlations go from 0 to 1. And the plus and the minus have nothing to do with the size. So a plus 0.6 is equal to a minus 0.6. A plus 0.6 is smaller than a minus 0.8. Forget everything you've learned about plus and minuses when it comes to correlation. And also do remember that positive and negative are not value judgments. A positive correlation is not good, and a negative correlation is not bad. Well, they might be, but that's not why they were named that. The positive and the negative have to do with the direction of how these things vary together.